This video covers how to find the velocity of an orbiting object. An orbiting object moves in a circular path around a larger object. Since it is moving in a circle, it is constantly changing direction, therefore it is always accelerating. We already covered this kind of centripetal acceleration earlier in the year, and it is defined by the equation A equals v squared over r. Without this gravitational force, orbiting objects would no longer feel pulled towards the object it is orbiting around, and it would simply just travel off into space in a straight line. So next we're going to derive the equation for orbital velocity of an object. We know that force is equal to mass times acceleration. This is just simply Newton's second law. We also know that force is equal to the gravitational force equation that we've already been working with a little bit. And we can set this equal to the mass times the centripetal acceleration. We can see that the mass of the object in which the force is being exerted on cancels, and the separation distance also cancels, and we can solve for velocity. So take note that this is the velocity of the orbiting object, and m is the mass of the larger object that the object is rotating around. This is typically a planet. And r is the distance between the center of each object, which is typically the center of a planet to the orbiting object. Let's do an example. Find the speed of the moon in its orbit. So we're going to use our newly developed orbital velocity equation. And for this equation, since the large object that is being orbited around is Earth, we are going to use the mass of the Earth and the distance between the center of Earth to the moon. So the mass of the Earth is approximately 5.98 times 10 to the 24th kilograms, and the distance between Earth and the moon is 3.84 times 10 to the 8th meters. So when we solve, we see that the moon's orbital velocity is approximately 1,020 meters per second.